Hello everyone. Today we are going to discuss the refrigerant cycle working principle. First, let's learn about what is a refrigerant. Refrigerant is a special fluid that carries heat through the refrigerant cycle. It absorbs heat in the evaporator, carries that heat through the system, and releases it in the condenser. The refrigerant can boil at a very low temperature when its pressure is reduced. Common refrigerants are R32, R410A, R404A, R134A, R600A. This is compressor. It compresses refrigerant vapor. This is the heart of the refrigerant system. It compresses low pressure, low temperature refrigerant vapor into high pressure, high temperature vapor. This is condenser. Remove heat from the refrigerant to the surrounding. This rejects heat to the surrounding and change the refrigerant from vapor to liquid while keeping high pressure. The The process occurs in three stages: hot vapor, saturated vapor, and the liquid. This is expansion valve, create pressure drop. This reduces the refrigerant pressure and the temperature and create low pressure liquid vapor mixer. This evaporator absorbs heat from the space or product being cooled to the refrigerant. Changes the refrigerant from liquid vapor mixer to vapor. Now we can talk about refrigerant cycle. Let's start with compressor. This is suction side and this is the discharge side. Low pressure, low temperature vapor came into the compressor. Compressor does not normally compress liquid refrigerant. It is designed to compress vapor. So this should be vapor. The refrigerant leaves from the compressor as high pressure, high temperature vapor. We can get, as an example, we can get air conditioner suction side temperature is about 6 Celsius and discharge side temperature is 70 Celsius. Also, it adds energy to the refrigerant. Condenser. Then this refrigerant goes through the condenser. Condenser job is to remove the heat from the refrigerant. The process occurs in three stages: heat vapor, saturated vapor, convert into saturated vapor, and finally as a liquid. The condenser rejects heat absorbed in the evaporator plus heat added by the compressor. Uh, That's mean we can conclude as this this so we can say condensed heat rejection is equal to evaporator cooling plus compressor work. After the condenser, we got high pressure, low temperature liquid. This low temperature means it's a medium temperature side. Then it goes to the expansion valve. It controls refrigerant flow and create the required pressure drop. Then we got low pressure, low temperature liquid vapor mixer from the expansion valve that enter to the evaporator coil. The evaporator coil job is to absorb heat from space or product being cooled. This this process is repeated as a cycle. Compressor, then condenser, expansion valve and evaporator coil. Let's understand this deeply using temperature entropy and pressure enthalpy diagram of a refrigerant cycle. First, we should get an idea about the temperature versus entropy curve, also called as TS diagram. There are three regions: liquid, vapor plus liquid, and the vapor. Also, this is a saturation line, and we can say this as a saturated vapor and this as a saturated liquid. Pressure versus enthalpy curve. We can call this as also pH diagram. Here is also like the TS curve, and here liquid side, liquid and vapor side, and the vapor side. This is a saturation line. Let's discuss about the curve. First process is 1 to 2. There is we can call compression, or this called as isentropic compression. Low pressure, low temperature refrigerant passes through the compressor, and we got high temperature, high pressure refrigerant. Refrigerant enter compressor as a dry saturated. So the dry saturated state ends point lines on the saturated line. After isentropic compression, air becomes superheated state. This is called superheated state, superheated vapor. Then in the process 2 to 3, this can call constant pressure heat rejection. Constant pressure heat rejection. In this process, high temperature, high pressurized refrigerant air reject its heat to surrounding by converting into liquid. This is a saturated liquid state. Saturated liquid state. Here we got high temperature, but not that much high temperature, and high pressure liquid refrigerant. Condenser reject heat to the atmosphere, remaining constant pressure. In this process, high temperature, high pressure air converted into the high pressure liquid, saturated liquid. In process 3, we can see this is as throttling expansion. In this process, high temperature, high pressurized liquid refrigerant convert into low temperature, low pressurized liquid plus vapor. This process generally carried out in expansion device. As example, capillary tube throttling valve or expansion valve. At the end of this process, that is step 4, liquid vapor refrigerant is obtained. In this process, enthalpy remains constant. The last process is called as heat extraction process. It is heat absorbing process in which heat is absorbed by liquid vapor mixture refrigerant and convert into air, saturated air. This process is carried out in and this cycle continue. This cycle is continuous. Cold refrigerant absorb heat from application and convert air vapor for the compressor process. Thank you. Please subscribe, like and comment.